Yesterday we talked about these four angle pairs. Corresponding angles resemble an F, alternate interior angles a Z, same side interior a C, and alternate exterior angles don't have a letter, but we talked about alternate exterior angles being on different sides of the transversal, and they're both being exterior. Notice that these lines don't necessarily have any relationship to each other, so location does not depend on how the lines are laid out, how they're oriented. Well, today we're going to look at how that is affected when the lines are parallel. So if you recall, we've talked about linear angles. So a linear angle or a linear pair. Okay, so a linear pair or linear angles, they form a linear pair. We have two angles, they share a vertex, where the four that we talked about yesterday do not. And because they form a straight angle, they equal 180. They're supplementary. And then we talked about vertical angles. They also share a vertex. They are formed by opposite rays, and we know that vertical angles are always congruent. So these two angles, both of those angle pairs are congruent to each other. So those are important for what the work we're gonna be doing today. So if lines are parallel, so what happens is I have corresponding angles, and what happens when the lines are parallel? So yesterday we looked, maybe like this, and this angle were corresponding. Well, so now what happens to those angles when the lines are actually parallel? Well, what happens is the corresponding angles theorem says that those angles are congruent. The alternate interior angles theorem says that if lines are parallel, then alternate interior angles are congruent. The alternate exterior angles theorem says the same thing, that if lines are parallel, alternate exterior angles are congruent. Now let's go over here and let's mark these real quick. We've got corresponding angles. So corresponding angles would be here. So this is just one example of corresponding angles. There are multiple sets of corresponding angles in each pair of lines. We have alternate exterior angles right here. This is just to give you a visual of more of what we talked about yesterday. We've got vertical angles. These are vertical. We've got alternate interior. That's these. And then last we have same side interior. So I did this because I wanted you to see, if you look at this pair right here, that purple pair and that yellow pair, those two angles are a linear pair. That means they add up to 180. Well, if you look at these two, those are purple and yellow. And if the other purple and yellow ones added up to 180, so do those. Well, those, if you notice, are same side interior angles, which tells us then that the same side interior angles theorem says that if lines are parallel, same side interior angles are supplementary. And supplementary means they add up to 180 degrees. Okay, and that logic is important. We have to say they're supplementary, and then we have to say that they add up to 180 degrees. And so then we have our same side interior would be these two. Okay, so this just gives us a visual of some examples of those types of angles. So with every one of these problems, when you go through them, you're going to have to stop and think, okay, what do I need to do and where do I want to start? So you can start in a lot of different ways. You always have options. So if you look at this 98-degree angle, we start with the one that we know. There are so many different places you could start. You could start with 1, you could find 2, you could find 3, 6, 5, and 7. The only one you can't find directly is angle 4. So if you just want to work your way around it, I know that angle 1 and that 98-degree angle form a linear pair. So that means angle 1 has to be 82. Angle 3 is a vertical angle from that 98-degree angle. So it's 98 because vertical angles are congruent. Angle 2 is a linear pair with either one of those 98 degrees, or it's vertical to that 82 degrees. Then I have to go somehow, I have to go from this vertex down to this vertex. And so we can use transversals to travel down. And I can see then that angle 7 has to be 82 because these two angles correspond. Now, that's not the only reason. It's also a linear pair, or not a linear pair, sorry, a same side interior angle with that 98-degree angle. It's also alternate interior angle with this 82. So there are any number of ways that you can think through this. Then angle 5 is 98 for a lot of different reasons. Linear pair with angle 7, corresponding to the original 98, alternate interior or alternate exterior with angle 3. You have a lot of choices. Angle 6 is 98, same side interior, linear pair, corresponding. But basically what you can see is you can pick this entire set of axes up. You can set this whole thing up and then you can just move it down and place it on top of that and see where those angles match up. So angle 2 or problem 2, you have several different choices of where you can start. If you want to start with angle 1, then you need to look for those 4 angle pairs. So what I see is that if this is angle 1 and this is 60, those are corresponding angles, and so that's 60 degrees. Then I can go to angle 2. I have 2 things I can do with angle 2. It's a linear pair right here with this 60-degree angle, which means it's 120, or I can also look here at angle 1 and angle 2. Those are same side interior angles. Now, let me make a point. These little arrows right here mean that those 2 lines are parallel, and these double arrows mean that those 2 lines are parallel. So you just put matching number of marks on there, just like we did with congruency, where we put those 2 match and these 2 match. And so you just mark them similarly. Now, we can go to angle 3. Angle 3, we have a couple of options too. So it all just depends on what you see first. Angle 3 and angle 2 are same side interior angles, but you can also do that angle 3 is alternate interior with that original 60-degree angle. The only one that you cannot find from the beginning is angle 4, and that goes with what we talked about having to move along the transversal. You can't go from angle 2 to angle 4 because they're not along the same transversal. So I would have to go from angle 2 to angle 1, find it, and then from angle 1 to angle 4. Well, if you see that angle 1 to angle 4, those are same side interior angles, so angle 4 has to be 120. It's also same side interior with 3. So you can go 2 to 1, and then 1 to 4, or 2 to 3, and then 3 to 4. So with problem number 3, there are, again, several ways you can look at it. Most students want to start here with this 60 degrees and that y because you get good at recognizing those vertical angles, so that's 60. Then you have to decide where to go from there. So what I see first, what I would recommend is this pair right here. Those are corresponding angles, so that means that angle Z is 75 degrees. Well, if Z is 75 degrees and that other angle is 60, these 3 angles together form a straight angle, which is 180 degrees. So 180 minus 135 is 45. Now, just so you can see it, you also have this same side interior, this 75 and these 2 angles together give you 180 because they're supplementary. So you would still have the 75 plus 60, same math, same numbers you just used in the last problem. But then you would subtract and get the 45. So it's just a different way to do it, but you're using the same numbers. With number 4, you might want to start with X, and so you go to start with X and you look, you put your, you start with your transversal, you try to travel from one angle to the other, and you notice that there's no angle that matches with this angle X. And so you got to back up, start again, and you got to be willing to do that. Just try something and then go on to something else if it doesn't work. So then I notice I can go angle Y, and I want to trace my parallel lines because we want to make use of those. And I notice that angle Y and that 50 degrees are alternate interior angles, which means that angle Y is also 50 degrees. So if that's the case, then you've got a couple of options. One thing you have to remember is that triangles equal 180 degrees. The angles of a triangle add up to 180 degrees. So if angle T is 50 degrees and this angle here in the middle is 110, that leaves me with 20 degrees here for H. Well, then that means now I know what X is because it's alternate interior. Now I'm going to skip 5 for a minute and come back to it. I want to go ahead and do number 6. So number 6 is an algebra setup. So we look at the angles that we have. The information that I have is that those are corresponding angles, and I know that corresponding angles are congruent. So I would set 9x minus 20, whatever that angle is equal to 4x plus 45. So I want to find the one x in the whole world that makes these two statements true at the same time, makes them equal. So I would subtract 4x from both sides and get 5x, add 20 to both sides to get 65, and I'd find out that x is 13. Then, if x is 13, I could go back up to either one of these angles and do 4 times 13 plus 45, and I get 52 plus 45, which is 97. Oops, so that angle is 97. I almost made a mistake. That's 97, but that means that angle 1, if you look here, angle 1 is a linear pair. Okay, those two angles right there are a linear pair. So I would take 180 and subtract 97 degrees and get 83 degrees. Now with 7, when you look at 7, what you'll notice is the two angles that have the variables, and obviously those are going to be the ones that I use, those don't have any direct relationship. They're not linear, they're not vertical, they're not the 4 angles that are on our angle pairs on transversals. But we can move them around by using the angles on transversals. So I'm going to move this x over here because those two are corresponding angles. Well, now what I see is that this and this, those two angles together, form a linear pair, which means they add up to 180 degrees. So I have x plus 11x is equal to 180, or 12x is 180. You just simplify that, solve it, and you get that x is 15. Once I know that x is 15, then I know that this angle is 15, which means this angle is 15. I can plug in the 15 to get 11 times 15 to get 165, or 180 minus 15 is 165. Either way, those should add to 180. That's how we set up the problem to solve it. Well, that's 165, which means angle 1 is vertical, so it is also 165 degrees. So we want to use the qualities of the lines being parallel to find the different angles. So remember, they can be corresponding without being congruent. These, like I said, these angles here are corresponding, but they're not congruent. But as soon as we make the lines parallel, these things happen. The corresponding alternate interior, alternate exterior become congruent, and